everyone. I'm Mike Urbans, and welcome to It's Your Water. I'm glad you found us. Today, I want to have a discussion on microplastics in water. It's all the buzz. PFAS is taking over the buzz in the industry, but there's also a sub-buzz, let's call it, of microplastics. And I have Justin Mest. He's with A.O. Smith. And if you've heard him before on the podcast, and I said, hey, you're very knowledgeable in the industry. We're on this subject. We're fairly knowledgeable, but I just wanted to bring it out just to have discussion between us two and you guys out there, just to share what insights, discoveries, anything regarding microplastics, where we are as of July now of 2025 in this discussion. Thanks for joining us again, Justin. What exactly are microplastics? I mean, they're small, very small plastics.
It's literally what it sounds like. It's sub-micron size plastics. So, right, when we talk about filters, right, we talk about macro filters, we talk about nanofiltration, we talk about RO, ultrafiltration. So I guess the closest comparison would be that 0.1 to 1 micron range of filtration. That's the filter equivalent of microplastics. And it's literally just very small plastics. But want to make sure we call out, because this is still something that I encounter a lot when I talk about microplastics in the industry, is the research community has very clearly defined definitions of microplastics and nanoplastics, and the industry is finally sort of catching up. But a lot of people in the water treatment world still lump together microplastics and nanoplastics into one category, and they are not the same thing.
Well, you blew my mind. I was like, what the hell? I didn't know there was nanoplastics. Because microplastics are easier, but nanoplastics now fall, and now they are much smaller.
Yep. Now you're talking about nanoparticles. Now you're talking about a lot of microplastics can be reduced with, once again, that sub-micron filtration, that 0.1 to 1 micron range.
Mm-hmm.
A lot of those filters can reduce microplastics.
Like the Ultra Pro membrane.
Yeah, so, the A.O. Smith Ultra Pro membrane, Master Water customers know it as the Ultra Pro. Yeah. Other branded A.O. Smiths might know it as something different, like Custom Care UF, something like that. But those suckers crush microplastics. But the most critical thing to note on that front is microplastics. Honestly, the hardest part about treating them is making sure you don't put them back into the water.
Right.
Like Michael and I were just talking about a customer who had an ultrafiltration membrane, but they were drawing in a disinfectant because they also had bacteria. They didn't want their UF to biofoul. Well, they were drawing a disinfectant through a vessel that contained plastics, and it was being drawn through a polyethylene tube, like a typical brine tube. And that disinfectant solution was going to the treated side of the membrane.
Right.
So this customer was getting shots of polyethylene microplastics into their treated water every time after they were generated. So it was like, okay, the levels were still lower coming out than they were going in, but they were like, well, we're finding new microplastics that weren't there before.
What's going on?
And it was like, well, it's polyethylene. I'm pretty sure I know where that's coming from. That's a really good example of the complexity of
the whole situation, and that's a good point. Who tests for microplastics? Is there a lab?
Labs will test for microplastics. I don't recall the actual standard for microplastics. I don't recall the EPA number or anything like that.
But still, there are labs that say, hey, can you test? That's good to know. I don't know any of myself, but we use a couple, National Testing or Resin Tech. I don't know if they'll. I gotta put that to Mary Ann. I say, hey, can you do this? But because so is the only devices that we think. Nanoplastics are how do you get those buggers? That's almost like a dissolved plastic.
Nanofiltration and RO.
RO?
Nanofilter membranes will take them out, but nanofiltration membranes are still, ironically, I don't agree with this because I think as an application specialist, I think it's an oversimplification of the benefits of nanofiltration, but a lot of people still call nanofiltration just bad RO. But it's bad RO that costs more money because it's not as mass produced.
This is RO, yeah.
I mean, once again, I disagree with that because there are unique applications for nanofiltration that I think we're not properly leveraging as an industry. So yeah, in reality, people are just going to use an RO for nanoplastics because of cost reasons. But right then and that, you have if you want point of entry, now you're talking about basically having like a small water treatment plant in your basement for a residential application. So is that really practical? I would argue not. But, it's also really important to note that the subject of microplastics and nanoplastics, it's still pretty darn new. Like, the World Health Organization still has a pretty substantial hit list of like, hey, here are the research needs. And one of them is even like, we still don't have a definitive read on what these are doing to our bodies. Like, we're concerned.
Yeah.
There's definitely concern, but there's really... the only truly definitive thing about microplastics and nanoplastics is this is what they are.
Yeah.
Practical means of, and once again, because they are physical particulates, really all you need to take them out is a filter that's tight enough.
Tight enough, yeah. Like an RO, is if you really want to nail it. But then there's the other people are saying, well, the RO tanks have a poly liner in them. Some of them do. From China, I've seen, poly liners instead of just pure stainless. And they use a steel tank and they put a poly liner so they don't have to put stainless in the tank. And can that reintroduce the microplastics? This is where we're discussing here.
You have plastic fittings on the treated water of your RO line. Or if you run a typical like polyethylene line out of the outlet, because you certainly shouldn't be plumbing your RO permeate in copper. I sure as heck hope you aren't plumbing your RO permeate in copper, because then you have a whole other sort of
there's problem because of the the aggressiveness of pure water. It wants to redissolve minerals. So you're damned if you do, damned if you don't. And who's going to run stainless steel over to your faucet?
It's a very legitimate, very real concern. Like all plastics will erode over time, especially in an aqueous environment. You run water through them and it's plastic, you're going to potentially reintroduce some microplastics, right?
Yeah.
But I think it's also critical to understand, right, the goal isn't always reasonably nothing left, right? If you could have very elevated microplastics coming in off the street or coming in from your broader plumbing in your home, and you treat it at the point of use, even if you add a little bit back in after you take it out, if you take practically everything coming in out and then you add a little bit, you're still in a better spot than you were before. So
that's what people say. Well, I'm only getting 80% arsenic reduction with an RO. I was like, well, I'll take the 20%.
Yeah, I'll take 20 over 100.
Yeah, I'm like, over the hundreds.
But that's a really important part, too, in terms of, like, once again, this is so new that, like, we don't have established regulations, like health regulations and stuff like that. So we don't even really have a reasonable... I would argue we don't have a definitive target for like, this is what an acceptable microplastics range is. It's just, once again, sort of like, hey, we know there's a lot of it out there. We know that there are potential health concerns. We don't know a whole lot more conclusively beyond that. But microplastics, I think, is totally going to be the new PFAS. And pretty reliably, as we learn more about contaminants, how often do you get good news as you learn more about contaminants?
Right.
Other than like eventually people figure out like creative, better ways to treat them. But the contaminants themselves, usually as we learn more, it's not good news.
Yeah, but and as human consumers, everybody, we've kind of created this situation. Unlike, we've had this, I don't want to blame, people like the chemical companies bring us, better life through chemistry, right? But we can also use less plastic as us, as consumers. I use a stainless steel bottle with an RO at my house and try to reduce all the plastic we can.
And if you do use it, dispose of it responsibly.
Yeah, but it's there. It's there. It's now we have a plastic dust circling the planet because, look in the mirror. It's nice to have a little plastic bottle especially when you're traveling abroad. So, because we trust the water more than the plastic that may be coming off in it. But still, we'll have more podcasts on the topic as it evolves. I just wanted to bring it out there and have, Justin, you get out there quite in the world of water. So do I. We're both geeks. We really like how the universal solvent, has made us a living.
It certainly has.
Yeah. And, we just like to bring insight to this podcast. And, so yeah, that's about really it. I mean, I haven't heard any advanced research going on. Do you hear WQA, WQRF?
Yeah, so I will say certification is a big piece here with microplastics. Updated certifications are in process that are dedicated towards microplastics, because right now the NSF/ANSI certifications have I'll call it a placeholder for microplastics reduction, but there are some unique dynamics of microplastics that they have acknowledged, hey, we need a dedicated standard for this because this contaminant is not the same as, just like a little bit of particle dust or something like that. This is a bit of a different beast. So there are products that are currently certified. Basically, if you get class 1 particulate, you can also, with the appropriate additional processes, of course, make a claim for microplastics reduction, but they are nevertheless working on a dedicated certification for it because, once again, there's a little more nuance than what I would argue class 1 particulate fully covers.
Okay. Well, I'll wrap it up here. Thanks again, Justin, for letting us pick your brain. And Trust the Frog, everyone. Thanks for listening. Bye-bye.